Right, welcome back to this last video of Word2Vec, and in this video we just want to quickly take a look how you could train your own Word2Vec model if you would like to do this. As I kind of discussed in the last video, I think this is only reasonable if you have a corpus with a very domain-specific language, such as financial language, for instance. If you don't, then I think it's still reasonable, but only like from an educational point of view to explore this and gain more insights. I think you always gain more insights when you do this for yourself and when you experiment and play around. So let's do this together. I prepared a notebook, which you can find in the description of the video, or the link to it, better to say. And we're going to use a relatively small corpus to train a model, but that also makes it possible for every one of us to train this quite quickly. It's the 20 news groups corpus that you can directly grab from the sklearn package. And yeah, as the name suggests, it's from different news groups with different topics, postings from different people. Usually, like in addition to the data, we need a way to estimate and to train the Word2Vec model. Here we're using from the gensim library, the Word2Vec model. Gensim is a very nice and well-written package, in my opinion, that among many other things also gives us the opportunity to train our own Word2Vec models in a very efficient way. So, and what this expects is at least a list of documents that are usually tokenized, so like split into unique tokens. And what you also usually do is then when you tokenize, you pre-process the data in some form. So for instance, here I'm using a simple pre-processing method from gensim. Of course, you can do this in a more sophisticated way and depending on your needs. So the original document, like the first document here, would look something like this. Okay, so here we can see this newsgroup character, like the one person who's posting it, and then somewhere later here on the right is actually the actual content of the posting. And the processed version of that document that's going to be handed over to the model is looking something like this. Okay, so here the simple pre-processing routine basically removes punctuation and numbers and any other special symbols and lower cases here. And that is how you can picture it. However, I mean, it is already very well explained how to train your own Word2Vec model on the gensim's page itself. But as a additional kind of comment, what I think is really helpful to do and to know is what I've been preparing here. So if you are completely new to Python, then maybe this is going to be a little too much, and also if you have little experience. However, maybe this is still an opportunity to learn about it. But what makes gensim also so powerful is that you usually what you're not supposed to do is, even if you could do it here, is to import all the documents in the memory. Because gensim is built in a way such that it can also work with generators of Python, and a generator is not loading all documents at one time in the memory. It processes it document by document. I know this is a very non-technical explanation, but if you want to find more about this, you probably better look for the explanations regarding iterators and generators in Python. However, what you have here is the chance to define a generator, and then you can have a really large corpus, which is larger than your memory of your computer, and still being able to train the model using all the data, all the text information that you have here. And to do so, this is also explained here directly in the gensim documentation. So here there are also this memory discussions. Sorry, let me show you here. Is somewhere here. Yeah. So what you need is this example here is it's good starting point. So it's again explained here. If the corpus is small enough, you can of course give it directly as it is, as a list of tokenized documents, or create a memory-friendly iterator here. And you do this in a simplest case here by defining, for instance, a class which basically just defines the iteration and basically tells you here whatever you have here for every element in your instance that includes the documents, you yield it, okay? And here you yield the pre-processed version of it. And yield is here the important part because that makes sure that this is treated as a generator as far as I know. I'm not here the complete expert here. And this makes it memory friendly. And this is what I'm also doing here. So if you take a look at my iterator here, I'm also yielding the pre-processed documents, but I'm also adding something here, which I think is really good to do so, because whenever I initialize here a list of documents, I train phrases first, also here in gensim explained and included. Phrases, here is the reference to the original paper, is basically looking for like if you start with it 2-word combinations, you can also extend this to a higher number of word combinations that do appear more often together or proportionally way more often together than by themselves. So for instance, New York together is very likely occurring many more times than the word new and York by itself. Okay, and if that's the case, I mean, then the score that is calculated here is large, and if the score exceeds a certain threshold that you can define for yourself, then whenever you go over a sentence including New York with the underscore is then treated as a unique token. And this is what I'm also including here. So basically, whenever you initialize this corpus here with that class, then it starts to, if you set use phrases to be true, then it learns first about phrases in the corpus, here again with a yield iterator, so memory friendly again. And once this has been trained, then what is outputted here are tokens of the processed text document and including identified phrases here. Okay, so in that case, I think I already have it here in the memories currently. For the first document, it looks something like this, and as you can see here, final regular is identified as a 2-word combination that obviously often appears together, and this is why it is treated as a single token here. Or what do we have here? Regular season, for instance. So if that's sports, in my opinion, that completely makes sense. All right, but as I said, this is like just the background information. I would say the important aspect for you, technically, if you want to train this for yourself with Python, the most important aspect is here that whatever using, if your texts come originally from an SQL database, from a list of CSV or text files, iterate over them in this way that it includes the yield statement, and that is going to be memory friendly because that is good practice here. Then if you would like to train a model, whenever you have set up a corpus, so I'm doing this here, you can directly hand this instance over to the Word2Vec model, and then it's going to be trained. And if you want to find out more about all the arguments you could set, and there's a large amount of arguments you could set, feel free to check out the documentation of the gensim page, because I think it is really well written, and that is not necessary to talk about it in a video that's supposed to be not that long here. Of course, if you would like this to be really easy, what you could also do here, maybe let me quickly demonstrate this to you. So we have still the original documents, which is this list here. So we could also say the pre-processed documents are like the simple pre-process of doc for doc in documents, and then this is something looking like this. Let's say how long it takes. So then you also have here a list of lists. Every entry of the list is now a list of tokens that come from one specific document, and you could also hand this over here directly to the Word2Vec model, and it's also going to work here. But then the larger your corpus gets, the larger this instance will get, and in extreme cases this may exceed your memory. And this is why I think even though you have a small corpus, it's good if you're getting used to defining a class with an iteration method, including the yield statement, and always treat it like something that you would like to have in a very memory-friendly way. Once you execute this here with the default parameters, and I would also suggest you set some logging information here, because it is included in the package and it is really informative during the process of the training. You can see what happens here, and then the model is going to be trained. And once it has been trained, of course, you can do many things. Always, it's a good idea to, for instance, with this dir function or method, take a look at the what attributes and methods this class have. And here I would say among the most important things is the WV. In that case, yeah, what is it? It's some form of class again here. It's the keyed vectors, and this includes all the trained word vectors here within their, and in addition with their methods. So for instance, here, if you execute it like this and set the index to key method, that is a, from index, like word with ID 0 is equal to, like, or something which ID 0 is the word this and that. So you set up for a dictionary, and you can find out about the vocabulary, so which type of tokens are all included in your Word2Vec model. Here's just an app like 50 tokens. Of course, you can take a look at your word vector for itself. You could also extract the normalized word vectors, like L2 normalized, such that they all have a length of 1, which is obviously often very helpful. And you can do stuff like find similar words. So for instance, here, even though it is not a large corpus, most similar to government, if you take a look here at these examples, all, or the majority of them all, make pretty sense to me. So yeah, this is basically it. So if you are interested in training your own models, I hope this kind of serves as a good starting point, and especially with this here as a maybe also good extension to the overall documentation of the gensim package. And this is how you can train your Word2Vec model. In the next videos, we are likely going to talk about a natural extension of Word2Vec, which is doc2Vec, and is constructing directly vectors for the documents themselves, again with a similar logic, that they have similar vectors if the document has similar meaning. And until then, take care, and then hopefully see you soon in the next videos.